Hello good viewers, welcome back once again. In our today's video, we're going to evaluate the following given infinite series. We have this infinite series 1 over 1 factorial plus 8 over 2 factorial plus 27 over 3 factorial plus 64 over 4 factorial plus all the way to infinity. Now we're going to find the exact value of this infinite series. So I'm going to start by letting x equals this infinite series, and there's something really cool we need to observe here. Now for the first term there, 1 is the same as 1 cubed, right? Then all over 1 factorial plus 8 is the same as 2 cubed, then all over 2 factorial plus 27 is the same as 3 cubed, all over 3 factorial plus 64 is the same as 4 cubed, all over 4 factorial plus, and so on. And when we write this in sigma notation, we will find out that this is equal to sum as n goes from 0 to infinity of n plus 1 cubed, then all over n plus 1 factorial, right? Amazing. Now let's see how we're going to evaluate this series from here. Now what am I going to do first? Now if you make a substitution letting n plus 1 equals, let's use another variable, we can use n, that is letting n plus 1 equals n. You can see that n is equal to n minus 1, right? Okay, now if you check when n is going from 0, then this other n will go from 1 to infinity, right? So this sum equals sum as n goes from 1 to infinity of n cubed divided by n factorial. And from here we're going to make use of one of the properties of the factorial of n, right? We know that n factorial is same as n into bracket n minus 1 factorial, right? So from this denominator here we have sum as n goes from 1 to infinity of n cubed divided by n multiplied by n minus 1 factorial. And from here we have some nice cancellations, right? So this equals sum as n goes from 1 to infinity. N cubed divided by n we use n squared, right? Then divided by n minus 1 factorial. Then what do we do from here? Okay, now what we're going to do, we're going to make a substitution again. So we're going to let this denominator here, n minus 1 equals n, right? And when we do that, then this n will run from 0 to infinity, right? Then up here we have n plus 1. Let's take a very look at it. N minus 1 equals n, so we'll find out that n is equal to n plus 1. Therefore n squared will be n plus 1 squared. So here our infinite series equals sum. Now n goes from 0 to infinity. Up there we have n plus 1 squared, then divided by n factorial. And when we expand this binomial right over here, we have sum as n goes from 0 to infinity. That will give us n squared plus 2n plus 1, then divided by n factorial. Now here we're going to split the denominator. We have sum as n goes from 0 to infinity. We have n squared divided by n factorial plus sum as n goes from 0 to infinity 2n all over n factorial plus sum as n goes from 0 to infinity 1 all over n factorial. Now there's something really cool we need to recall here. Remember that e to the power of x is equal to sum as n goes from 0 to infinity of x, which is the power of e here, raised to the power of n, divided by n factorial. So we can see that what we are dealing with here is somehow related to what we have here. So what are we going to do next? So if you take a look at this sum here, we find out that this one here can be written as 1 to the power of n. And if we let x equals 1 here, we find out that this sum here is exactly equal to E. Amazing. Now let's go back to the other sums. So here we have S equals sum. As n goes from 0 to infinity, we have n squared divided by n factorial n times n minus 1 factorial, plus here this constant 2 will be written out, right? So we have sum as n goes from 0 to infinity, n all over n multiplied by n minus 1 factorial plus e. So from here we have some nice cancellation once again. So this becomes sum from 0 to infinity. N squared divided by n will give us n, then divided by n minus 1 factorial plus, so here we have 2, sum from 0 to infinity. So n cancel n, so we have 1 all over n minus 1 factorial, right? Oh, I think I've made mistake somewhere, right? Remember that if n is equal to 0 here, we get 0 minus 1, which is negative 1 factorial, and that is not defined, right? So let's go back and check where this mistake is coming from. Now take a very look at this place. If n is equal to 0 here, the whole of this simplifies to 0. So if n is equal to 1, we get 1 over 1 factorial. So this is same as sum from 1 to infinity, and here from 1 to infinity, right? Okay. So this is 1 to infinity. So sorry for these mistakes. So from 1 to infinity, and here 1 to infinity, and here 1 to infinity. I'm so sorry for this. And here we have plus a. Now from here we're going to make substitutions once again. So we're going to let n minus 1 equals n is equal to n plus 1. With the following substitution, everything will be transformed to sum from, now this time around, remember n is going from 1 to infinity. So here, if n is approaching 1 here, we have 1 minus 1, which is 0. Therefore, n is going from 0 to infinity. Here, n is same as n plus 1, then divided by n factorial. Then plus 2, sum, n goes from 0 to infinity of 1 over n factorial. We write this as 1 to the power of n, then plus e. From here, we split the denominator. Here we get sum. As n goes from, what is it going from? Let's see. If you split, we have n over n factorial. Remember what happened here when we're going from 0 to infinity, instead of writing it from 1 to infinity, right? So no need of putting this from 0 to infinity, but rather from 1 to infinity. And here we have plus sum, n goes from 0 to infinity, 1 over n factorial, which is same as 1 to the power of n, plus 2e, right? Because this is exactly e plus e here. Now, we have here n over n factorial. Let's go back to this particular summation here. Here, the only difference here is that this one is 2 times, and here we just have n over n factorial, right? So we can say that this is also equal to e, right? Or we can even prove it. Now let's prove it. So s is equal to sum from 1 to infinity, n all over n multiplied by n minus 1 factorial, right? Then plus, here this is another e, right? So we have here e plus 2e plus e will give us 3e. Okay. Oh, now this cancel this, right? And here we have s, which is equal to sum from 1 to infinity of 1 all over n minus 1 factorial plus, here we have 4e. So this is equal to sum. Here, if we make a substitution, n minus 1 equals n, we will see that we still have from 0 to infinity of 1 over n factorial. We can write of 1 to the power of n plus 4e. And from here, this is equal to e plus 4e will give us 5e. And this is the right answer. Thank you for watching. Please kindly subscribe to my channel. Also like, comment, and share. Bye-bye.